Hey, Keenan, you're the only one here?
Looks like it right now.
Wow, okay, yeah. All right, so you can have a one-on-one, a free one-on-one office hour if you want. So, well, today is the last class, isn't it?
Yes.
Well, you guys can get back to me if you want class in next week, one or two classes next week. I'm happy. Either way. Because the week after that is spring break. Next week is week 12. If you want a class, I'm happy to give it. But today, by the way, as you might know, I opened up the midterm for a retake if you guys want to take it. The highest score will be kept. So.
Okay. I'm definitely gonna retake it then.
Yeah, but yeah, I think until midnight. You can take it anytime.
Okay, awesome.
All right, we can just wait for more people to turn up before we start coding. We'll just pick up last week's. Yeah, I mean, was it last week? Yeah, last week's code and run with it, or we can create one from scratch. It doesn't matter. So I'm just going to wait for more people to show up. If you have any specific questions or something that you'd like me to talk about, I'm happy to talk about that. Otherwise, I'm not going to talk about anything. I'm just going to wait, just like this. Is that okay?
Yeah, so my internet actually went out like halfway through last class, so I'm a little bit behind.
All right. Why don't you click on that link that who was coding last class? I forget.
Last I saw it was Sean.
Yeah. I think so. All right. So there must be a link that he posted on the sub. So take a look at that link and code. Maybe try to catch up. If not, we'll try and do things from scratch too. It's not a big deal. Except we won't spend time talking at great length about some of the things that we talked about last class when we were coding, because last class's code was less than about 70 lines on screen, including all the comments, and that took us almost an entire class to write. So, but this time we can start with that, whether we pick up the link or not. But recreating the 70 lines shouldn't take more than a minute or so we can do that really quickly. Yeah, we'll just wait around. Noah and Keenan, you're the only guys here. We're just waiting around for a few more people to show up. You can have a free-form conversation if you want, or you can just talk with me and I can respond. But I don't have anything particular to say until more people join, so I'm just going to stay, hang around like this. If it's kind of spooky, having a prof in front of you, I can just turn the laptop around so I'm not facing you. And then when more people join, we can actually formally start class. Is that better for you guys?
Yeah.
Yeah. I'm sorry, I missed that. All right, I'm going to assume you said yes. All right, so I'm not staring in your face, so you guys can talk if you want, or share screen, or do whatever you want. We'll just wait for a couple more people to come, or we'll start at 8:15. All right, we'll at 8:15 we can start coding. You can call me anytime you want to resume a conversation. Just call me, and I'm right here. Okay, I'm just not looking at you guys.
All right, sounds good.
Okay, well, I think we should, I don't know, should we start? We can start now if you guys want, and if you're up to coding, well, it's only 8:10, but we could start if you guys want, okay? We can start coding and the latecomers will just have to catch up. I mean, it's, we can't keep accommodating latecomers all the time. Is that okay with you guys? Can we start coding?
Yeah.
Yeah, go with it.
Thank you.
Yeah.
Thank you. I think it was Van who was coding last class, not Sean. Well, Van, it was you, wasn't it? Last class?
Oh, this Tuesday it was not me. But it was me previous to that though.
Oh, so you were coding on Thursday and then Sean was coding on Tuesday.
Yeah, I think so.
Yeah, okay. Well, where's he gone? You know, Sean is not here. You know, that's why, you know, I think I made this point last class. A lot of regulars like Kaylee and Ali and Ashwath and Sean. You can't take this. This is not an optional lecture, okay? In cs2a, you can't say, well, there's these 24 lectures and I can, you know, pepper my presence through these classes. It does not work like that. If you miss one class, you're basically sunk right there until you basically put in twice the amount of effort to catch up before the next class.
Oh, there's always the
subjecting
YouTube
yourself
videos
to
though,
undue
right?
hardship.
Oh, there's still the YouTube videos though, right?
Yeah, there's still the YouTube videos, but they're not, I don't think the videos are sufficient to actual class participation, okay? It's like, that's why I say, if you're going to watch the YouTube videos and then try to catch up, you're going to subject yourself to undue hardship because you're basically saying, I'll do twice the amount of work at least compared to the students who were in class and coding, right? And so yeah, I don't know, right? I mean, you guys have got to somehow at least warn the future students somehow in some forum or reliable online forum that, you know, that people can't hijack and so yeah, make it known to other students saying you can't take this class easy and go like a check in and check out like a hotel. All right, so you know, this doesn't work like that. Okay. Yeah, yeah, at least pass this message on to all the regulars, okay? Because I'm pretty sure, I don't know, maybe Kaylee and all these other people have caught up already and they're solid with the material, but who knows, right? It's better to know that you have to be in class unless you are absolutely sure. Right. So if one of you can pick up the code, just, you know, either the code that Sean posted, I think it is on Reddit, okay? So I think there is a link. Or if you don't have it, just open up a brand new browser. We'll just code from scratch. We'll recreate it from scratch in, I don't know, I think less than 5 minutes anyway. And I'll just call out the code and you can type it in blind mode. And we'll have a reconstruction of what we had. And then from there, we can start playing with more of it. And I'll try to remember what challenges we tried to set for ourselves. Okay, yeah, I think this time, yeah, I think what we tried to do last class was create this long linked list on the heap. And now in this class, what we can do is try and find something in the linked list and remove it if it's there. Okay, I think that is a good enough initial exercise. And if we manage to complete it today in class, I'll give you a lot more interesting linked list problems. We can either work on them in class or you can work on them at your own time, discuss in subreddit, any of these things. Okay.
Okay.
Yeah.
I can pick up the code if you want, but my the Wi-Fi is still kind of bad.
I see.
So it's
Okay. Well, how about you? I'll use your backup, Van. So if nobody else offers, then what we can do is you can switch off your camera feed and then just use your screen share so that, you know, some bandwidth will be better utilized for.
Okay.
All right. Who else can code today? I don't know, Keenan, Noah, Kai. If one of you can code, you can just pick up the screen. And
I'm actually connected from my phone because my computer's having issues right now. It's like it keeps rebooting and stuff. But
oh, wow.
Yeah, I need to get it figured out.
Yeah, maybe it's that fancy monitor you're connected to it, and the device driver is The one that was behind you last.
No, I mean, I didn't change anything. I think it's just an issue with a Windows update or something.
Hmm, I see. Okay. Yeah, I don't know. But yeah, my computer, even though it's a Mac, I discovered this morning that it had upgraded and the operating system overnight. So all my Windows were gone, and I had to relog into my things.
I hate that.
Noah, Noah or Kai, are you guys able
Yeah,
to?
totally. Let me just log in.
Hey, cool. All right, Van. So we have a savior.
So,
And hey, Noah, see if you can find Sean's code from the Reddit. If not, we'll just recreate one. I think it's the most recent link. If actually, let me take a look on my iPad so I don't have to leave the screen. And also let me make this full screen so that we'll get more.
Sounds good. It's just gonna take me a second to log in.
No worries.
mhm,
I'm gonna maximize this.
mhm,
better. By the way, how many of you guys are majoring in computer science or planning to major in computer science? Nobody.
I'm in
I am.
electrical, so no.
I am.
Electrical. One of you said electrical, right?
Yeah,
Electrical engineering.
yeah, that's me.
Yeah. All right. You probably have to do a bit of electronics and digital circuits too, I think.
Yeah, just a little bit, but it was mainly
Yeah.
electrical. But,
I still think if you, especially if you're going to do electrical engineering, C++ is a fantastic choice. Yeah. So because you can play with loading specific voltages on pins and things like that, and you'll know exactly, right? You'll know exactly what how to drive your USB interface to power a particular device and all, right? You can calculate these things. So yeah, and then C++ lets you do that more easily than I'm pretty sure Python or something. So yeah, good choice. But so nobody else is nobody else planning to major in
Yeah, I'm
computer
majoring in
science?
computer science.
I am as well.
Oh, no one knows computer science? Great. Zane, I think, is also planning to major in computer science, right,
What
Zane?
would be a good name for today's coding room?
Sorry, someone was saying something and
Yeah, what would be a good name for today's coding room?
Which one?
Today's coding room.
Oh, yeah. Today's coding room. That's what you named yours, even the one you're going to
No,
share.
and what should I name it? What is today's class relevant to?
Say linked lists.
Sounds good.
Oh, I didn't know. Coding room asks you to name each of these things.
It actually like name the workspace. So
Oh wow. Fernando, yeah, welcome to class. Is everything going okay with the tutors? I was just telling the students who were in class before that we know in cs2a, I don't know, pretty much the same in other classes. I think cs2a is not like a hotel that you can check in and check out whenever you want, right? If there are 24 classes or 22 classes in 11 weeks, you got to make every one of those. Okay, so you can't say I'm going to skip, these guys. So it doesn't work. People who do that will usually end up, very bad grades. Okay, so hey, Noah, no, you can't find the code. The Kai, not Sean's code.
no, I mean I can look for it. If
No,
someone
let me take a look.
sends it to
Hang
me,
on,
maybe.
let me take a look. Oh, it's CS2A. All right, CS2A, midterm question, quest 6, March 10 coding rooms. Okay, so who posted this? Van posted March 10. Oh, this is an ancient one.
Oh, yeah.
Yeah, we'll just do it from scratch. Okay, all right, so let's just do it from scratch, Noah, if you don't mind. It's going to be pretty straightforward to build what we already had, and then we can, do the things later. Hey, Noah, just go back to what you had and we'll go from there.
Yep.
All right, so let's put a comment right at the top and say, we're playing with linked lists. So, people who look at this code will know that's what we're trying to do. So on line 1, just put a comment saying we're going to be playing with linked lists here. playing with a linked list or something like that. Or playing on linked lists in plural is fine. Yeah. All right. So now hash include iostream. Let's also using namespace after that. Using namespace standard after hash include iostream on the next line, line 2, and then hit enter.
Sorry, can you say that one more time?
Go to the end of line 2 and hit enter.
Sounds good.
Yeah. And then one more enter and say using namespace also.
Oh, yeah, yeah. Oh,
semicolon, semicolon. And then two enters. Now we're going to create the node class, which a single bead. Okay, so say class node, class, yeah, node, and then space. No, it's not open parentheses. It's got to be space, squiggly, space brace, yeah. Okay, enter.
oh, yeah, my mistake.
And then a semicolon at the end of the closing brace, after the closing brace. Okay, so let's go back inside the body. Now, we want to say just, we'll make everything public here because we're only playing with the logic. So colon, public colon, and then, public colon. No, public colon, and then this is not doing the auto indentation. I think Sean's was doing. So pull the public all the way to the class CLASS indentation. Remove the indentation before public. The word public. Before. Yeah. All right. So yeah, conventionally that is the indentation. Now and hit enter. Now you can indent in 4 spaces. All right. Now let's say int data, int space data, int. Data, enter, semicolon, enter, and then we want to say node space star node, node space star node, node space star node. Yeah. Oh, no. I think it was next is better. Next, not next yet. Node space star is next. Yeah. Semicolon. That's it. Okay. Now that's our node class.
Professor?
Yeah.
So I remember you said like convention wise you put an underscore before the name, the variable.
Yeah. I did say that, Zane. You're absolutely right. Okay. And that would be a good convention to follow. Here, I'm not doing that, mainly
Okay.
because we're gonna not worry about things that interfere with our understanding of the concept, because in this class, what I'm hoping to get across is just the idea of a linked data structure and how you can traverse it and pull things out. So in the process of trying to understand that, I don't want to push other concepts like, okay, well, this is a stylistic detail and things like that. But what you brought up is absolutely right. When you're totally comfortable with the logic and how to manipulate the linked structure, the next step is to say, okay, now I'm going to code it, but I'm going to code it in a way that is going to make most sense to me, to make it easy for me and fellow programmers. That's the time when you're going to say, I'm going to style it in the right way. Yeah.
Okay. Yeah.
And the other reason is because we're just looking at the logic here. I said no underscore data because data is easier to type and then, easier to read also. That's the only reason. And you'll also notice that, another bad thing we're doing here is that we don't have any private, this class doesn't have any private members. It's basically a structure. Everything is open, right? Everything is public.
Yeah.
So it basically defeats the whole purpose of C++, right? Because C++ has this data hiding power. We're not using it. Yeah.
Right.
So,
yeah, okay.
Yeah. So, and again, that's a very valid objection. So just like you, if you had said instead of, hey, why are we not doing the following a naming convention, you could say, why are we not doing it the wrong, unadvisable, unwise way of making everything public? We're not even using C++ here. Okay. Very good question. And I'd say, yes, that you're absolutely right. And the reason for that is because the C++ concepts we've already gone over. You just need practice. Now, you can practice that independently of learning this concept. Now, I don't want that to get in the way of learning the concept, because the concept is hard enough by itself.
Yeah, that's fair.
Yeah, okay. All right. So that's what I'm trying to do here. Okay, great. Now let's go to main. Inside of main, hit on line 13. Enter, and then you say here, yeah, let's create 3 node pointers. So say node space, star P1, a comma, comma. No, actually, just P1 is fine because no, let's do everything in a loop, right? Star P1, that's fine, right? So semicolon. What you did was correct. Yeah. And in fact, since we only have one node, let's just create the node right there on that line. So instead of the semicolon, let's say node star P1 equals new node. Yeah, okay. And in fact, because we're using the default constructor, we don't need the empty open parentheses. Just say new node, just like new int, new char, new right? The compiler knows we'll create a new node because it's just a structure, right? That's like we're using it's just structure. And the default constructor, this is called the default constructor. There's question about a default constructor, non-default in the forums. Nobody has taken up the opportunity to get those low-hanging points. Yeah, okay. So that's the default constructor. When you say new node, it'll just call the default constructor, bam, like that for you. I'm going to create a node with no parameters. So that's what it is. And that essentially has what Noah typed before. Noah typed open parentheses, close parentheses. Yes. That's how you'd expect to call a default constructor, because a node constructor, you call parameterized constructor, you're going to call parameters inside the constructor, inside the parentheses. Yes. When you have a non-default constructor, you're going to put the parameters for the constructor inside the thing. But if you have a default constructor, you're saying, well, no parameters, then it only makes sense. Just like a function that doesn't take any parameters, it's an open close parentheses, which is exactly what Noah typed. Yes. However,
Yes.
yeah. So, however, in this case, this is something that we have to remember. And I think it's cognitive load initially anyway, because it's unintuitive. What is intuitive is what Noah just did. But here in C++, if it's just a default constructor, you have to omit the empty open close parentheses. Okay. All right, great. Now on line 14, yeah, I hit enter. Yeah. Now one more blank line, and we'll say at this point, we'll say a comment there. Yeah, put a comment. At this point, P1 points to an empty node located somewhere in the computer's heap, not our stack. All right, points to an empty node in the heap and not our stack. Yeah, okay, and it's important, right? It's important, and this is important because anything on the heap we have to remember to release to the operating system before we die. Okay, so you can put on the next line another comment saying this is important because anything on the heap needs to be given back to the operating system at some point by us using the delete keyword. Okay, anything on the heap needs to be given back to the operating system, OS, we can say to the OS, yeah, at some point using the keyword delete. Yeah, using delete. Yeah. Is that enough, or do you want to say anything else you want to say? That's fine. But I think that comment is pretty self-sufficient. Now let's put our loop there. Next line and 2 enters. Now here's our loop, and I'm going to see again. So that's why I say these things are practice, muscle memory. This loop that I'm going to just read out, I'm going to say what this is, and Noah's typing it. Just do it 100 times, okay, blindly, because this loop you should just be unwound from your mind as though it is a standard structure. Okay, so now let's do I'll do the easy one. Okay, so let's say a node star current equals P1. Node space star current equals P1. Right, and on the next line, you're going to say for size t, I equals 0, I less than 100, right? One hundred. Oh, I see. All right. So after node star P1 on line 14, let's just create a constant, right? Say list size, right? Const int list size equals const int const, make it a const. Int size t, const size t, because it's going to be a size, right? Instead of int, say instead of int, say size underscore t space and then list underscore size in all uppercase, list underscore size all uppercase equals 100. Yeah, semicolon, and then enter after that. You know what I'm thinking? Yeah, all right. I think I was thinking the comment on 17 and 18 belongs before, but let's not mess with it. Okay, it's fine because it's the comment is right at that point. That's what it is, right? All right. Now we can go back into our for loop and say I less than list size, right? I less than list size for int I equals 0. I less than list size I plus plus. Yeah, thank you. Now here we're going to say, yeah, let's do it this way. All right. Node star temp. Do we need to do temp? No, we don't even have to do temp here. This is a really cool thing. Okay. So we're going to say current arrow next, current arrow next, instead of node star, just say current arrow next. Next equals new node. Yeah. And on the next line, you're going to say current arrow next arrow data equals. Yeah, in fact, I think if you get rid of the spaces around the arrow, yeah, it'll be easier because we're going to have 2 of those right now. Yeah, so equals. Now here, what we're going to do is a current arrow data space equals current arrow data plus within parentheses, you're going to say rand %10 rand open close here because it's a function. Rand open close %10 and then +1 to make sure it's always no, outside the parentheses say +1 to make sure it's always ascending. It can be equal to the previous one. Now on the next line, you're going to say current arrow next current. On the next line, you're going to say current arrow next. Oh, in fact, you don't have to do that. That's fine. Okay. What do we have to do? All right. Now outside the for loop. Yeah. We one more thing. I'm sorry, Noah. I'm just on line 24. On line 20, we're going to say yeah. Okay. Current equals current arrow next. All right. Thank you. So yeah, Noah's already typing from memory. Okay, so he has his boilerplate. That means, right? So when you see people type things like this, you know that they have this boilerplate already. Okay, all right. Now one thing we need to do is before we start the for loop, right? We got to populate the first node with something. Otherwise, because that data element has to have something, right? So let's go to line 18. Hit enter. Line 18. Enter. End of line 18. Hit enter. Now, what we want to do is basically say P1 arrow data equals rand %10. So we're going to give it the first number. P1 arrow data equals rand %10. So that's the first number. Rand open close. Yeah. Right. You need a semicolon after the 10. Now let's see, is that enough? Because P1 next will be set in the loop. So when you exit the loop, the last guy won't have a next actually initialized. So on line 26, when you get out of 26, at the end of line 26, right? Now you can enter. Now you can say current arrow next equals null pointer, right? Current arrow next equals null nullptr. PTR, right? Semicolon. Now, how do we know that this list has been created correctly? So we're going to create let's create a print function or something that will dump it. So here's what we'll do. On the next line, 28, enter one more time. Yeah, right. Now here, what we can do, actually what you had, let's put one more line there. I think it'll be nicer. Okay, now we'll say cout left shift. What we'll do now is say P1. No, let's do it this way. Let's not do a method, okay? Because I don't want to bring methods and confuse the concept here. Here's what we're going to say. Cout 2_string, or you can call it node_2_string, node_2_string. No. Oh, I see. You type 2 underscores. Okay. No, what I meant was node underscore to underscore string. Node to string. Okay. Now the only parameter to it is p1. Right? And then after that, you can do an endl and left shift and endl.
Do we not do like a node dot to string? Or
No, that's what I said. Yeah. Typically, you would do a node. In this case, it won't be there is nothing called node. We don't have an object called node, right?
Yeah.
But what you probably meant was, do we not do a p1 dot to string?
Yeah, my bad.
Yeah. But I know that's what you meant, right? Well, two things here. It's not p1 dot to string. It'll be p1 arrow to string because p1 is a pointer, right?
Okay.
Now, that is technically the right way to do it. However, we're not doing it that way because I don't want to conflate what we're talking about today, which is, trying to manipulate a list, the concept, with something to do with classes and, syntax and higher level stuff.
Sounds good.
Yeah. Okay, cool. All right, good. So now at the end of that, left shift and endl. All right. Now, all we need to do is just define that node to string function above main, and we're good to go. We can actually compile and run it. So after the node class, enter one more time, and you can say string. It returns a string space node underscore to underscore string, and it takes a node pointer as a parameter. P. You can just say P. Oh, all right, PDR. You're going to use P. You're going to use that variable a lot. I think make it a single letter. It'll be easier for you. You're happy with it being a PTR?
Yeah, sorry. Kind of in line with the str.
No. Oh, I see. Okay. All right, cool. Now, what we want to do is, let's say string result equals, we'll start with a blank string result equals blank. I'm going to build up the string using a very simple way, but there are more efficient ways of building up the string, and you should find out using istring stream and things like that. But we're not going to do that right now. All right. So all right. Now enter. Now here, what we want to do is while PTR is not equal to null, right? While PTR, not equal to null, because that's the same as null pointer. That's fine. No, either way is good. No, what you had. All right, cool. Did you use null the other place, or did you use null PTR the other place? Null PTR?
Yeah.
Oh, they use null PTR here also.
Okay.
Yeah. All right. Now here, what we want to do is concatenate while PTR is not null, right? You want to say result equals result plus result equals result. No, I don't think plus equals works. You can try it, but I think it's not overloaded for string. So you can say result equals result plus PTR arrow data. Now, since that's an integer, you want to convert that to a string first, right? So you say to underscore string PTR arrow data is a parameter to a library function called toString, which is going to take an integer and return a string. Yes. You can look it up. ToString is a function. It's just a library function which converts an integer into a string. Now, if you read the modules and previous lectures and so on, you'll see there's 100 different ways to convert integers to strings. Okay, so I'm just using one easy way here. All right, but plus, no, actually, it's not the Java style toString. It's got to be to underscore all lowercase string.
Say it one more time.
On line 16, it's not toString one word. It's it's actually snake case in C++, not like Java. It's also to underscore TO underscore. Yeah, and then lowercase s. And then instead of the semicolon, no semicolon, you want to add one more thing there. Say plus, and then you give it and say string string, and then open parentheses, and you want to give it the quoted string, double quoted string. Let's just say 2 dashes and an arrow sign. 2 dashes greater than within quotes. 2 dashes within. So open quote, open double quote. Yeah, Yeah, like that. That's what it's going to print between the data items when it prints your thing list. Okay. No, you want to put some kind of a thing, an arrow symbol saying that this links to that links to that, and so on, right? So put an arrow sign, not there. Yeah, there you go. Now, after you exit the while loop, you want to print the null pointer. So you say result equals result plus. At the end, yeah, result equals result plus. Plus, and then you can say the word result plus. You can say again string. It's got to be, yeah. That's the thing with C++. You cannot use a naked string like that, because a naked string is a pointer, and then the plus operator doesn't know how to add a pointer to a string. It's a very subtle thing, and it's not even necessary to know at this point. But I don't want us to risk running into that error from the compiler that will throw us off track, right? So that's why I'm saying we'll just use the correct typecasting right here. String. So within there, you're going to say end or end or null. Yeah, null pointer is good. Null pointer. Yeah, and null PTR. Just say null PTR, because that's the name of the variable you use, right? So PTR. And then endl slash n after that, slash. Oh, no, you're right. No slash n. The slash n is printed by the cout. So that's good. Put a semicolon after that, and then return result. And because our while loop only has one statement, you can even get rid of the braces if you want, right? So it's just while, and then this whole function is like 2 lines. There you go. Okay, so that is if you run it now, I think we should see a list of 100 numbers. All right, spoke too soon. Let's see. What is the error? J does not name a type. Where are we
Oh, there's a
using
J on line 9. Never mind.
I didn't see it. Did you fix it?
Yeah, he was fast.
Oh, okay. So what else is it saying? Oh, just change the int to size t on line 32. Change it. Will get rid of the warning on line 32. Oh, further down. Yeah, line 32. Change the int. Yeah, the first int. Yeah, change that to size underscore t. Is everybody following what Noah and I are doing? Right. So I just don't want us to be the only 2 people who are coding in class. Is everybody following us? Okay,
Yep.
Can someone please speak up?
Yes, I'm following. I understand.
Okay. All
Yeah,
right.
for the most part, I get it.
All right. So if any of this is unclear, you got to ask us. Okay. Thank you.
Definitely. Yeah.
All right. Can you compile and run again? We'll see if it goes. Oh, it's running and it's not. It's just. Oh, it's in an infinite loop of some kind.
Yeah, this while loop. we
Oh
never-
yeah. I'm so
remove
sorry. You do
pointer.
need a body, Noah. Kill it. Control C out of it.
Wait, Professor, quick question. So for that null pointer where he's checking in the while loop, the condition,
Yeah.
that's built into C++?
Yeah, null pointer is defined in the library. In one of
Okay,
those,
gotcha.
if you go into the one of the header files that is included from the iostream.h,
Yeah.
you'll see a line somewhere in one of those files that says null pointer is equal to 0.
Okay.
Yeah.
So you
Thank you.
you
That's
wouldn't
yeah.
throw,
So what Noah is doing right now is what we forgot to do. That's what resulted in the infinite loop.
so you don't need to throw like a null pointer exception or anything?
No, we should never throw in a null pointer exception. No program ever, even in Java, you should never throw a null pointer exception. The null pointer exception is only thrown only by the system.
I mean, like to check for one.
That's what he's checking. He's checking on line 15.
Oh yeah. Okay.
He is, isn't he?
Yeah.
So you got to check as long as and the reason he's checking is essentially to avoid the null pointer error that you referenced, right? Because if he doesn't check, there's a risk that you'll actually access the null pointer inside the while loop.
Yeah.
Right?
So is that
Because
what
if
he's getting
PTR
at
is
the
null, you
back?
can access. Then you'll cause the system to say NPE, null pointer exception, and kill your program. You don't want the system to kill your program with NPE. That's why he's doing a check there.
So he's getting one at the end because it's running out of.
No, he's not getting one at the end. That's something he. All right, okay, Noah, you want to change that word null pointer to something else? Just say end of list.
Oh, okay. I see. It was just a string.
Yeah, that's whatever he puts there.
I just change it to null, is that fine?
Yeah, I don't know. I don't, it doesn't confuse me, but you can say and, yeah.
Okay, that makes
Okay.
sense. Now I get
I
it.
got a question after Zane's done.
Yeah, sure. Hey, run it. Yeah. Okay. There you go. Hey, it's actually printed out quite nicely, right? All the arrows are lined up, so this is kind of cool. Yeah. All right. Yeah. What is it, Van? Did you have a question?
Line 17. So it's just the syntax I'm not familiar with. It says pointer to next. Is next a variable, or is it kind of just like how do we read this?
All right. So does anybody else want to explain this, or do you want me to explain it? Okay, because I know that there are other people who actually have the answer, know the answer. Does anybody want to explain this answer, or do you want me to do it?
I mean, on line 9, like every single node.
Okay, so yeah, I just noticed
Another
that. So
node.
yeah, you did define it. Okay.
There you
Yeah,
go.
it's defined inside of the object. That's why you got to be, arrow, and you got to go inside the node to find
Yeah.
next.
It's
Gotcha,
basically
okay.
because like every node is basically like the whole point is to have a point like a connection to the next one. That's how they're being linked. So you have to have that reference.
Yes.
Oh, so they okay, so that to be linked
Except it's not the
also.
whole point. Right? It is an important point, but it has to store the data too, right?
Yeah. And the
All
data.
right. Yeah,
Gotcha.
yeah.
Okay, that makes sense. So this so the line 17's been saying whatever's inside of pointer is passed to is accessed and then put inside pointer.
Which line? Line 17.
Yeah.
So what line 17 says is
Mhm.
go inside PTR, which is a
Mhm.
pointer to a node. Inside
Yeah.
that node, you'll find the next guy.
Gotcha.
Yank that guy out of there and make my current pointer point to this guy instead of whatever it is pointing to now.
Okay.
All right. Okay. So a whole bunch of things happens. Like 10 characters tells a whole story right there.
Gotcha. Okay, that makes a lot of sense.
Okay. So it's very important. And what Noah did right there. So it's not just the code here. Okay. That is why it's very important to attend class and see what's going on. Right. So and see some, Noah's got a bit more experience, it looks like. So so by watching him code, you get a lot more information than just the concept being discussed, because what I said before is like super duper important in coding. Watching other programmers code is like a critical component of not just teamwork, but also learning new skills. Because when you watch people code, you will get a very good idea and a sense of what needs to be boilerplate and what needs to be concept that you can regurgitate and what needs to be something that you have to construct on the fly. Yeah. So there are these distinct categories of knowledge. Knowledge that I can just pull out of an encyclopedia, knowledge that I need to remember, or knowledge that I can reconstruct from facts that I already know. So that you can only get by practice and by watching other people that already have skills wield them. And that's why I keep reiterating it's not enough. It's totally not enough in classes like acting or creative writing, programming, ceramics, pottery wheel throwing, swimming, right? Archery. You can't say I'm going to go and read through the modules and appear for the exam and I'm a skilled surgeon after that, right? It doesn't work like that. These are, people don't understand that programming is actually a hands-on thing. It's like a craft. You can't just read about it and go out there and hope to be employed. So you have to, we actually in computer science in our department, we have to figure out a way in which this message comes through loud and clear to all of the incoming students, our freshmen, saying this is not a class you can treat like, once in a while. This is like an essential skill you got to learn every bit of. And all right, so we'll do one more thing here. Get rid of the blank line, Noah. What we'll do is I want to show you this thing which you're likely to be stuck on in question number, maybe not in question number 9, but if you go on to do my cs2b, hey Noah, you can clean up a line, get rid of line 10. Right now, let's create a function. Right, get to line 22 and hit enter. And I want to show you something. Okay, and enter. All right. So here we want to do void, and you say delete list starting at and delete list from node. Okay, you say delete list from node, and then yeah, pass it node star p. Okay, all right, PTR. Now, what we want to do here is, what is special about this is that this list is going to be deleted iteratively. Okay, deleting it recursively is easy, but I think it's also tolerated, and it's okay to do that in cs2a. But the very first quest of cs2b, which is exactly almost 99% the same as the last quest of cs2a. That's why I said to June also, right? If you finish all 9 quests of cs2a, you already have a freebie. You not only get credit for the 9 quests in cs2b, but you also have the very first quest of cs2b already done, because that's almost the same as quest 9 of cs2a. However, one of the salient differences in cs2b is that in the spec I say, when you do the delete for the linked list, do it iteratively, not recursively, right? So a recursive solution is okay. You get points for that in cs2a, but you won't get it in cs2b, I think, right? But I'll show you how to do it iteratively, and why you should do it only iteratively. Linked data structures, trees okay, because it grows exponentially. You can hope that it's not going to be too big. But a linear data structure like a list, you can have a list that spans millions and millions of nodes, right? So if you do it recursively, your stack frame is going to grow exponentially large, because every call is going to give you another stack frame. Nothing in the past can be forgotten when you go into another function. Yes. So when you're deleting down recursion a million times, you got a million stack frames just sitting there and sleeping, waiting for all of these guys to come back so it can just die, right? Just waiting to die. And that's all locked up resources. And the risk is, if a malicious programmer, if you know that there's some program that Microsoft or Facebook or some Pentagon or NASA has a program out there that has a linked list, that has a recursive destructor in it. Some programmer in those companies was stupid enough to write a linked list with a recursive destructor. You can actually crash their entire system by sending in a request that will essentially build up a very, very long linked list, right? When they try to free it, they'll run out of stack space and die. And you can take advantage of the couple of seconds before their load balancer fires up another program to launch a malicious attack. Because, a couple of seconds is all many of these bots need to infiltrate your system. Yes, because you have these watchdogs, and all you need to make sure is just kill this watchdog, kill this watchdog, kill this watchdog. Between the, like Mission Impossible, right? You get 0.7 milliseconds of time during which you can tunnel your virus through. I don't know if that makes sense, right? Because those are the kinds of things that are exploited by hackers. Yes. So that's why, if you're programming defensively, it is very important to think about these possibilities and say, well, there's a likelihood that my program will crash, rather than just infinitely time out their thing. That's what we should do. Iteratively, we'll just time them out rather than crash. Okay, so let's put a comment on line at the beginning. Go to line 23, hit enter, and then say on line 23, hit enter. Start a comment that says this is going to delete this is going to delete the list iteratively and not recursively. Okay, which is iteratively, right? So iteratively and not recursively, because most students will just do it recursively. And I described one of the answers to a 2B question that you have to answer in the forums is why not recursion, right? Why do you have to do it? And a lot of students actually are in the past, if you go back to the 2B subreddit and look at the discussion of this question, you'll see that a lot of students are not convinced too, right? And some of them are actually very forceful and say, no, recursion is so beautiful, you should use recursion there, right? And there is no reason why you shouldn't use recursion. And unfortunately, I don't know if these students ever got presented or read the reason that someone left saying, no, this is why you shouldn't use recursion. And they never, came back and said, yes, oh, I'm sorry, I thank you for that. So I don't know, maybe they're just under the misconception still. Okay, all right, so let's go into the function and we'll define this, because it's going to be a hard one. That's why I'm doing it for you. So let's go inside the function and line 25 and hit enter. Yeah, there you go, indent in. And we're going to say here, let's say node star current equals PTR. I hope this works out. Yeah, I think this should work. Current equals PTR. In fact, we're going to do exactly the same thing as before, I think, right? So on the next line, you say, copy the whole loop, while loop from the previous one to here. It's exactly the same, right? Copy that the whole thing, 15 to 18. Even the while, yeah, put it in this one here. Yeah, and then here, what we want to do is we want to say while PTR. Okay, here's what we're going to do. We will do it slightly differently. Yeah, current. While current is not equal to null PTR, you want to say current equals current arrow next, and then delete PTR. Right. So there you want to say instead of result equals on line 28. No, you can't delete PTR first. The first thing you want to do on line 28 should be current equals current arrow next. Now, after he's done this, let's make sure every one of us is on the same page and understand exactly. There's only 2 lines, right? There's only 2 lines, but it's like super duper important to understand exactly what's going on here. And students who are not here today, they better watch this and understand, okay? Because it's like critical. It's a critical concept. Okay. Now on the next line, get rid of line 28, 9. We don't need 29 because it's not printing anything and returning anything. Right now, we want to say here, all we need to do is delete PTR, not PTR equals PTR arrow next. You say delete PTR on line 29. No, you don't even know the whole thing. The whole thing. Just delete PTR. Let me see if it works. So you got the list.
What are you asking me to do right now?
Oh, delete PTR, delete space PTR, and then semicolon.
Okay.
No, get rid of the word PTR. You just want to say delete space PTR, delete space PTR, semicolon. That's it. Okay. Now, I'm just running this through in my mind to make sure it works. Okay. So we got this list, and you should also, try and do the same thing and tell me if it works. Or if you think there's a problem, you should tell me there's a problem. Okay. So there's this list that's given to us, this pointer. My current is now this pointer. And what do I do in the list? What I'm going to do is my current. Oh, yeah. Okay. All right. So that's wrong. Okay. There's a bug there. Yes, there's a bug. Isn't there? Isn't there a bug? Can people tell me? Okay. Can you spot the bug? This loop is not going to work. Why?
The while?
Yeah, this while loop, there's a bug in there, right? Because I was running it through in my mind, and I know I've found the bug, and that loop will not work. What I was trying to do, right, is I got this list. Okay, can you guys see me? Please, if you can, turn on your cameras, because Van is the only one I can see right now. So I got this list, okay, and this is what I'm trying to do, but I'm not doing here. Okay, I want to iteratively peel off the top node, the head node. Yes. Now my current should be here, but this guy I should delete. Now this is my current. Next time in the loop, current moves here, and this guy I delete. Okay. So every time what I'm doing is removing the first guy, deleting it. Is everybody okay with that so far?
Yes.
Van is the only one who's nodding, and I can't see the rest of you.
Yeah.
Zane, you good too? I don't know. Fernando, June, Johnny. Oh, there's quite a few more people, but nobody's actually showing up on screen, and I can't see. Yeah, please try, guys, if you can, to switch on your cameras. It'll look much better. Now, I want to make sure that everybody understands this, okay, before we fix the bug. Because what's the point in fixing the bug if you don't even understand what the bug is first? So Van, probably Zane, Noah, Van, and I are the only ones who have said we understand what's going on. Nobody else understand what's going on? What the bug is?
I don't really understand. I'm just kind of trying to like follow along, sort of.
Okay. All right. I'm going to explain this pictorially. Right. Thank you for speaking up, Keenan. Okay. Please tell me if you can follow this pictorially. Okay. No C++ here. Yes or no?
Let's see.
All right. Okay. Well, that's good. Okay. So this is my list. Okay. I got list items here. Okay. This is my list. See, I don't want to speak like for 5 minutes and at the end ask yes or no, and one person says yes. Okay, hopefully, right? In a conversation, it's got to be two ways, right? If I say something yes, you got to keep feeding back. Otherwise, we're not moving forward. Yes, especially since I can't even see you guys. Right?
Okay.
All right. So I've got this list, and these are the elements on that list. What I want to do is this list, each of these elements were given to me by the operating system. Yes?
Starting on your left hand?
Hmm?
Oh, like a node. So it starts on your left hand and then you're saying like.
Yes, I'm
here.
sorry. Maybe
Yeah.
it's, is it reverse? This is my left
It's
hand.
inverted for us. So your left is my right.
This is my left.
So-
This is my left.
Yeah. Oh, that's
It's
yeah,
starting,
I got you, I got you.
let's say it starts, let's say from bottom to top, okay?
Okay.
Right. Okay, so this is my list.
Uh-huh.
Okay, this is my list. This is my first node.
Mhm.
Each
And
of
that's
those nodes
current.
was given to me by the operating system. That guy's pointing to null.
Okay.
This guy is pointing to null.
Okay.
Yes or no?
Yes.
So the function says, what I want to do is, as soon as this list is given to me and said delete this, I'm going to grab, so in this function, I'm going to grab this guy. Okay,
Uh-huh.
that's the guy I want to delete first,
Delete the first one. Okay.
right? Only the first one, because I want to do
Mhm.
each one iteratively.
Yeah.
However, after deleting it, I don't want to lose the next guy. Yes, because so what I'm going to do is I'm going to
Yeah.
grab this guy, and then I'm going to create a variable that points to the next guy.
Uh-huh.
Now I delete this guy,
Yeah.
and this guy can now become this guy.
Okay.
I repeat that in a loop.
Yeah. Yeah.
That's what I want to do. Yes.
Yeah. Yeah.
Okay. Is everybody okay with this? Not just Van and me and Noah.
Yeah, yeah.
Good, Keenan.
It's like
Zane,
flopping
Zane?
back and forth and clearing the previous value, right?
Yes, yes, yes. We're just walking the list and clearing what's behind us.
Yeah. So like ideally
Yeah.
we're slowly trying to cut a string instead, like a mental physical string, a rope, and we're snipping off bits until it reaches the end.
Yes, we're snipping off as everything that's behind us. We're snipping off and giving back to the,
And then hit zero. Gotcha. Okay.
All right, good. So the bug
I
here.
have a question really quickly.
Yeah, sure. No, yes.
So, do we want this delete list from node? Like, are we deleting the whole list after the node, or are we just?
Oh, I see your,
deleting the whole
yeah, yeah.
node, or-
So Noah's asking, do we need to delete the node itself and everything downstream, or only things downstream? How should we
Or
do it?
also, is it, or maybe just the node, nothing downstream? I don't know.
No, everything downstream. So let's change the comment on line 24. It's going to delete the list, starting iteratively, not recursively, starting at PTR, starting at including PTR. We can put it on the next line because it's 80 columns, I think. Starting at and including PTR until the very end of the list.
So why don't we just change this while loop to say while current equals pointer? Just.
Can we do that?
Never mind.
Yeah.
I think I'm.
No, it's okay. We should try all these things. I'm always,
Do you mind if I just
enthusiastic.
write something and then you?
Yeah. Everybody should try lots and lots of crazy as, even guaranteed to break in C++. It's not going to work. You should try it, right? Because otherwise, how would you know? Otherwise, people who've been programming, especially the ones who've been programming in other languages, there's no way you can learn C++ unless you've been trying C++. Oh, that's how you do it in C++, right? So Python, I should get rid of that Python mindset for when I'm doing this. How does that happen? Only through practice. So I always encourage this. That's great. Thank you. So while current is so you guys want to try to fix the bug, or do you want me to fix it?
I was gonna try it real quick. What's the deal with this delete PTR? Do we actually need that there or no?
Delete is the critical thing, right? But delete is the thing that says, here's a node you gave me 10 years ago. I'm giving it back to you. You can release it back into the pool. So delete is that keyword you want to use on every single node that you got. You see how in that in your main you had a for loop that used new for every node.
Are you saying I can't just set current.next to null when current.next is equal to PTR?
No, you shouldn't change the contents of the node.
Oh yeah, I
You just want to
forgot.
delete the node. Yeah, you
Oh.
want to delete.
Okay.
So what I was thinking we'd do was, this while current is not equal to null, what we want to do is create a new variable called p, right? Node star q or something equals current. So you're holding on to current. Yes. Now current equals current arrow next. Yes. And then you can delete q. Does that make sense?
Sorry, audio cut. Could you say that last line again?
All right, so let's do it this way. Okay, hey, why don't we do it in code and then I can explain the code? Is that
What's
easier?
on the
Is that
screen
better?
correct?
Hmm?
Is what's on the screen correct?
Oh, let me take a look. Current while current not equals to null pointer, current equals current arrow next. No, q equals current. That's the first statement. No, the first one before that. No, that's fine. That's fine. Before that, one more line before that. No, not there. That should be inside the loop. You cut the line and put it inside the loop. The whole line. The whole line should be inside the loop. Yeah. So now what we got is in the loop, Q is going to point to the first element. Yes. And then the first element moves here. Current is now here. Now you delete Q, not current. Right? Because Q is what you want to delete, not current. Current is, the beginning of the list that you still have to delete. Yes. Yeah, I know this bit is going to be so obvious to you in just a couple of
What
months.
about
Okay.
I don't think this will delete the final element though.
Yeah. That you can delete the final element outside the loop. No, wait, hang on. It'll delete. No, I think it'll delete everything. Yes. It's okay if it takes time to understand, okay? Because even though this is like 3 lines, it's like super duper important. And it'll be, and the reason it's important is because all of this is going to become, mechanical memory for you in just a couple of months.
Oh, wait, I think I got it. So the bug in the last code,
Oh, I
we
see
didn't
it.
save the next one. So we just deleted what was given, and then there was no way to get the next one to.
That's right. We just deleted
Spot.
what we had and we couldn't move on to the next one. We didn't
Right,
have
there's
to do
nothing to
that.
grab onto. So you shot the head. Okay.
Now we can actually write this without having to use a new variable because we got past pointer PTR. It's not a const, which means you can change it, and it's a small function. So you can actually save. You don't really save anything because the compiler is going to do it anyway. But if you want to write it with one less variable, you can do this, right? Instead of Q, just use PTR. You say PTR equals current instead of node star Q equals current. On line 29. Line 29, you say PTR equals current. In fact, you don't even have to do that, right? Because you already said the very first time, oh, no, you have to do that. PTR equals current. You got to say PTR equals current, PTR equals current, and you can get rid of line 20, line 29, right? Current, get rid of line 29, and then change the delete Q to delete PTR.
Say that one more time.
You get rid of the delete key, hit delete.
But then what did you say after that?
No, delete this line. Delete this line.
Okay.
And then on line 31, where you say delete Q, you say delete PTR. It's also the same, right? We saved on the use of a variable. Then this should also work, right? Keenan, it's exactly the same as before. We're just using PTR as the variable Q. We didn't create a new variable called Q. Does that make sense?
Yeah.
All right. Now, this is an important piece of code because even in an interview too, right? If you're interviewing someone and you want to say, write a destructor for a list, or here's a linked list, write a destructor, right? And then on the whiteboard, it's only 5 lines. They should be able to write it in like, I don't know, 2 minutes in an interview. And then you can see whether they wrote it recursively or iteratively. And you can ask them, why did you write it iteratively? Is there a risk with writing it recursively? And so on and so forth, right? So it's a very good interview warm-up conversation starter. Yes?
Professor, yeah, I've read somewhere that like linked list interview questions are super common.
Yeah, but but this particular one, I don't think people ask because it's very simple. But also a lot of professionals also maybe, because I've hired programmers and I've, when programs crash and then we did code reviews and then we go in and say, well, who wrote that? Because that destructor is not supposed to be recursive. Yes.
Okay.
And these things you'll see and see code that's written by professionals.
Yeah.
Right. And the reason is because there are lots of professionals who didn't study formal computer science.
Like in a institution?
Even in companies, right? In fact, I know of subpar engineers who are working even in some of the FANG companies, even the top software companies like Facebook and Google and Microsoft. And the reason for that is because once a company goes beyond 1,000 employees, right, it's impossible to make sure that everyone is a rock star. Right, and you got to have resource-based programmers, meaning that there are things that need to be done in my company that don't require rock stars, right? Because just a resource, I'm going to use it for 10 years in my company, and then that product is going to be destroyed, right? We need it for some stopgap measure. So you want to employ a resource programmer then. So not everybody is going to be a clued up computer science person, but in order to be a critical contributor to any place, you need to be, critical, meaning you can touch pieces of the code in the code base, check in code, and because when you start working at Google on day one, you get access to the entire code base, right? Everything in the search engine and everything. You can download the entire thing onto your computer. However, you can check things in, right? But the thing is, there are people that are tasked with, are tasked, and also like Wikipedia, certain pieces of the code, certain people can edit, right? And you'll get multiple code reviews and things like that, core infrastructure code. But those places can only be entered by people who actually know computer science, right? Even though you may be working in these companies. But this is a knowledge that, because if someone goes in and crashes a system in a big company, like, a rich company, and they do a code review and find someone wrote that, and that was a cause of, the country's Pentagon being, hacked into by foreign nations or something like that. And this is the reason they do a code review and find out, it's not going to be a very happy day for that person. Yes. And so these are things that, or at least they'll know that, that person, how did they get into a non-critical, non-resource oriented job? They should be in the outskirts of the company, right? Working on non-critical things. Now, how did they get here? So this is important code, okay? And I think it's useful to know, and also reel off from your mind like a boilerplate, like Noah just did. And it doesn't matter that we didn't do it with objects and classes, because when you wrap this in objects and classes, that is the easy part. Wrapping things in objects and classes and putting, privacy and public, guards in there, that is the easy part of programming. The hard part of programming is coming up with the logic and solving the problem. Yes? That is why we didn't do objects in this class, because objects, you can read from the modules. We've already done a couple of classes on that. It's all pretty straightforward. When you want to take the algorithm and bury that inside an object, that's all straightforward, because this logic, which you've tested out without objects, you can take it and bury it inside an object. Now, this will now become a method inside of an object. And that object will have members like next and data that are protected by private, and will have getters and setters. Yes. So that is how a project gets built, right? I'm pretty sure there's a ton of videos on YouTube. You'll see, here's how an object-oriented project gets built. And you'll see lots and lots of diagrams and triangles and formal notation and things like that. All of that is only eye candy meant to impress people, or I don't know. But if it's done at the second stage. Okay, the first stage is basically brainstorming a clever solution, right? And that does not require objects or factoring things, factoring your assets into classes and ontologies. Okay, that's all comes later. First part is always getting the logic right, and so no objects needed. So this part is important, like super duper important. Is everybody okay with this so far? Now,
Yes.
I would like for you to do the actual part of today's class, which is what we started out with the plan of doing today. Is we're going to create one more method which you will fill in. Okay, so get to the line 33 and hit enter. All right, and then a comment there and say to do for classwork without the professor. All right, with the professor on standby. Right, with ampersand, with me on standby. Okay, to do for classwork, and then you can say I'll just be on standby. Okay, so which means you guys are going to do it, and you can call me if you're stuck. Okay, so yeah, classwork. You say classwork there. Okay. Also on the next line, well, let's define a function. So on the next line, you say. No, I see. No, I'm saying, oh, yeah, enter. Let's go to the next line. Let's go. All right. You say comment, open comments, and say this function will, what do we try to do? Okay, yeah. This function will search the given linked list starting at the given node for the given target value. We'll search the given linked list, given list. Yeah, list. For yeah, starting at the given node.
What are you asking me to do? I'm sorry.
Starting at the given node. And the next line. Yeah, go to the next line. Yeah. For the given target value. Target value. And if it exists, it will delete the element and return true. If it doesn't exist, it will just return false. Okay, that's what it is. Okay, if it exists, it will delete the element, remove the element from the linked list, right? And if it exists, it will.
Can you repeat that one more time?
If it exists, it will delete the element from the list. If it exists, comma, it will delete the element from the list and return true. It will, if it exists, it will. I think there's a lag. If it exists, it will delete that element and return true. And on the next line, you can say, if not, or if it doesn't exist, it'll just return false. Yeah. And do the signature of the function on the next line. We'd say bool delete element. Yeah, you can say from list, or you can just say delete element, up to you. Right. And the first parameter is going to be the list itself. Do we need the first parameter? I think we just need the starting point, really. Yeah, I think we just need the starting point. So we just say, yeah, node star ptr, comma, int target. Yeah, okay. No. Yeah, all right, that's fine. Okay. Yeah, okay. So that is what you guys have to write. And then, yeah. Great. Oh, yeah. So are you guys ready to do it now? I mean, if you're ready, I can turn the laptop around so I'm not in your face, and you guys can talk amongst each other. So I need to hear some voices. More of you need to switch on your camera so it's not boring gray. right? Some of you had your cameras on already, like Kai had his camera on before, unless he's gone off screen. And yeah, so some of you guys, please consider switching on your cameras. Giovanni and Zane and Fernando and June also. All right.
Yeah, I would.
And
Mine is just I'm just doing something, but
okay, all right. So anyway, don't let Noah type the whole thing, okay? Because he could just type the whole thing from memory like a boilerplate, and you guys would say, okay, that's done. So you should hey Noah, don't type the whole thing, okay?
Okay.
All right. So in fact, what if Noah's okay with that, he will just type, okay? He is not going to code at all. So someone else should speak out the code that Noah should type, and he'll just type, just like I've been doing. Yeah. And then you can Noah can obviously ask questions. Anyone can ask questions saying, hey, is that right? Do we need, is there an error? Things like that. Okay. Just like he's been correcting me, he could correct you too, but he's not going to type any of his own code. I hope that's okay. Noah, okay with you?
Yeah.
All right, good. So are you guys okay to complete this function? When you're done with this function, call me. I'll kind of do a quick code review to make sure, it's in 2 pairs of eyes and everything okay. But that I think is an important function, because that gives you, it teaches you a very important skill, which is basically suturing a linked list, a linked data structure. You got to do this anywhere, right? Whether it's a linked list or a tree or a graph, you got to know this, right? You got to know how to go somewhere, pull it out and cut it up and join it up so that it looks like nothing happened. Yes.
yeah.
No matter what data structure you do, you got to learn the skill.
Yeah.
Okay, so let's do this. Make sure you know this 100%, right? And even those who are not here today, get this message to them. This is the critical function they got to know. If they know this, they can pass 2A, with good grades, because cs2a, the last quest, needs this to be implemented. cs2b starts with this, okay? Builds on this. If you don't know how to do this, you'll fail cs2b for sure, okay? Because disconnecting nodes is basically fundamental to 2b. You're going to be doing that in your sleep. Because every single problem in 2b, you're going to have a data structure you're going to manipulate, which means you're going to go in there and take some nodes out and rearrange it. So if you're going to be doing that often in cs2b, you got to be like totally comfortable with that in cs2a. Yes.
Yep.
Okay. All right. So that is where we're going, and pass this message on to other students. You can't skip the last part of cs2a and hope that you can go on to do the rest of the computer science in C++. So it's like super important. Spend as much time as you want. We got almost like a half hour or more, right, for this. So make sure that every one of you in class understands what's going on. Okay. June has actually solved this problem. I reviewed her code submitted for quest 9, so she knows how to do it. And we talked about this before. And if she doesn't respond or doesn't participate, it's because we're speaking too fast, and it's not her native language. So if you're absolutely stuck, and instead of calling me, you can also ask June. Hey June, are you here?
Yes.
Okay, you can ask her. Just make sure that you speak a little slower, because English is not her native language, but she will be able to say, at least speak the code out slowly, and Noah would say, oh, all right, or this is what we can do. All right. So there are people in class who know the answer. If not, you can always call me, but I want every single one of you to understand how to do this. Okay. The most critical operation you have to learn in cs2a, taught to you at the very last class. No class next week. This is the last lecture. Okay. Unless you want a class, I'm happy to give, but this is the last lecture. I'm going to turn it over to you guys. Okay. I hope you had a great time, right? I know most of you didn't attend all classes due to various reasons, sickness and things like that. But I hope you got something useful from this class, okay? From day 1 to now. Did you guys learn interesting and useful things from data representation in C++ in CS2A?
Yes.
Yes, I did.
Thank you.
Yeah.
Thank you. Because that's really what every professor wants, right? At the end of class, at the end of the quarter, they just want to know is, was this useful, right? We just spent a whole 3 months trying to teach you some useful things. Was this useful at all? Because that feedback is also useful for us. And so you will be doing every professor, now that is week 12, a great favor by just sending them an email saying, this worked in class, that didn't work. I like this, I didn't like this, because every professor is going to spend the next week and over the summer break trying to fine tune their class for the next quarter. Okay, and what you tell them now is going to matter, and so that's very important. Thank you all, and I'm happy that this this class was useful to you. I hope to see many of you in my CS2B, okay? There are easy sections of CS2B and CS2C on offer at Foothill and outside of Foothill, right? Every college you go to will have easy sections, no matter, right? Even if you go to some other, high-ranking institution, same class will be offered hard, easy sections, okay? The people who really succeed in life will go for the hard and challenging classes because they want to get, learn as many skills as possible to go out there and conquer the world, right? But people who just want a Harvard certificate or something like that, I know this thing, and with this title, I can get a president job or a vice president job, and I have people do it for me. They're not powerful at all, right? So sooner or later, someone will call their bluff, and they won't, they'll have a glass ceiling above them. So that's why this is all like super critical.
Wait, Professor, you're gonna be back though, right? At the end.
If you call me, I'll be back. Absolutely, right?
Okay.
Anytime I'm here, okay? And it's not only at the end. If people, enough of you get together and want a group class before the final or even after the final over the spring break, I'm happy, okay? All I want is for you guys to master it and come back to me and do the hard section of 2B, okay? It won't be hard if you master the material. And you'll be proud of yourself, I can guarantee, right? You'll be happy at the end, saying, well, it's not just a piece of paper. I actually have something if I don't have a job, I have something that can feed me, right? So you will be set up with that. Don't do the easy sections. Come back to my 2B and you get credit for this too, right? And I'm very happy with you guys, at least the guys who are coming and persevering, okay? Despite sickness and everything, you're coming back and persevering, trying to master the material. I'm happy with that, okay? And pass the message on to everybody else too, that you should all try to master this material, and I will hope to see you all in my CS2B at some point. Maybe not immediately next time I offer it, but at some point, I remember, okay? Sometimes my students come in 7 quarters later, and I still remember by name, right? And I say, hey, you know what? 5 quarters ago, we coded on screen together. I remember that, okay? So I look forward to seeing you all again, but finish this function and call me if you're stuck, okay? Is that okay? Is this a good challenge for you to wrap up the class?
Yeah, this is good.
All right, thank you. Thank you. All right, call me if you want, if you're stuck.
Okay. Okay, so we can have a pointer equals let's see. Pointer equals runner. And then runner. And then I think we can do, so we can have an if statement. So the data, it's runner dot data, right? Or pointer dot data. Equals the target. So the syntax is just that you just say delete and it deletes it. Like up there where you wrote that.
Oh. Would we delete a node? So we delete the whole of the node, or is there a way to delete something that's inside of it? Or is it kind of like just a whole package deal now?
It says delete that element, so I think he means like the whole node.
Okay, okay.
Yeah. So if the runner's data is equal to the target, then you delete. Okay, so their node runner is the pointer. Okay, no, so the pointer is like the head, that's the beginning. So the
Okay.
node, well, runner is not equal to null pointer. Actually, wait.
Do we
Actually,
need
I
to
don't even
define
think-
another variable? So if we're taking like an input that we call pointer, so pointer is the input. We take the input and we put it in our node that we call runner, and that's going to be the head runner. So that's going to be the first.
Yeah,
or something
yeah,
like that.
that's right.
Gotcha.
Actually, we
And-
don't even need a pointer equals runner then at the beginning. At 42, you can delete that line, I think. Yeah, and then runners, runner dot next.
Do we need to create a line? Oh, yeah, right there. Okay, gotcha.
I actually think we will need the pointer once it's time to delete it.
Oh, yeah,
Oh.
okay. That might be a good idea. Delete runner.
And then return true.
Yeah. Yeah, that looks, let me just go through this. So we have the start, and then if we're checking while runner is not equal to null pointer, pointer equals runner. Runner data is equal to the target, delete the runner, return true, runners, runner dot next. So what would we need so for line 42, do we still need that?
Yeah, this code doesn't work. This is just gonna delete the runner. And then it doesn't really,
Will it be like null pointer
it just
exception?
deletes everything downstream of runner as well. It doesn't really
yeah.
relink the list with the data that we want to maintain.
So we gotta create a line that'll
Oh.
pass the second into the first then.
Yeah. If I'm understanding what you're saying, then yes.
Oh, so you're saying we have to bridge, we have to like bridge the gap between that
Yeah,
one being deleted?
So it's like the same issue as last time when the NAND was doing it. It was like, we're deleting the head of it so it can't pass the next one.
yeah.
Okay. Can we scroll up to see the same pattern? It should be identical then. For the whole passing the second to the first thing. So this is while. So while it doesn't, we first. We put so we put the pass on the top and then we pass it, then we delete it. So the last thing we do is delete it.
Say that one more time.
If runner data is equal to the target pass, and then the next line probably under 43. I'm just spitballing. I definitely don't know this for sure, but it's like under that, would it be, you would then put the line to pass to like copy what's in the second before you delete it, so you could then put the second in the first, from what I understand? Because right now, the way we have it set up, correct me if I'm wrong, it just deletes the first one before we can copy and pass it. So when the first one's deleted, there's nothing we can like pass. Or is this complete?
I don't think it's complete.
Okay, so wait, what are we lacking then right now?
We're lacking that right now. When you delete runner, it deletes runner and everything downstream of runner.
Gotcha, right. So if you
Don't
scroll
wanna
to
delete
the
everything
top of the
downstream.
other method.
Say that one more time. What about this method?
Yeah, so like looking at inside of like while loop 28, it says while current is not equal to null pointer, take current, copy that and put it into pointer, and then pass the current to the next one, and then delete pointer. So it finds the one, deletes it, but you first put it in a box, and the box is what we call pointer. Then you burn the box. But first you take the current and then you pass it into the next, from what I understand. So that allows it to be continuous without nuking the whole thing.
Right.
Couldn't you delete this list? Can you just delete the head and then?
No, because you don't delete, you need to delete every node.
Do you have to
Oh,
delete every node manually?
yeah.
Okay, so is that just like a node concept
It's like a C++ thing with like,
with nodes?
yeah, I
Yeah,
guess.
because I remember like in Java, if you like set the head equal to null, it just like gets rid of the whole thing.
Oh,
Yeah.
easy. That sounds nice. So then under here, in our function or in our method, while current does not equal null pointer. Oh wait, which one's ours? Oh, right, if while runner data is equal to target, take oh, wait, you have that line on the top. Oh, it's because of that if statement. Do we have to put the pointer equal runner inside of the if statement?
No,
So,
I don't think
okay,
so.
so it is a little bit different than the last one then.
Yeah,
Oh. Hmm. Do we do, okay, so it's the delete thing. Is it delete run? Can we do delete runner arrow data? Can we just delete what's inside of, oh wait, did we? Are we essentially like emptying a certain node instead of deleting the whole node, or? Because I'm a little, the word element is a little bit loose on me, like. An element would be something that's like a value inside of a variable. So is this like a value that we're trying to get rid of inside of a variable box and then leaving the box? So we leave the name.
sorry, say that one more time.
So I guess maybe you take it a step back. What is the purpose of this whole method we're forming right now?
To search the given list, starting at the given node for the given target value. And if it exists, it will delete that element and return true.
And return
Not
true.
return false.
So the node itself stays, but the value is empty.
No, the node gets deleted.
Oh, isn't that what we did above, or is that something else?
But in this one, we delete everything downstream as well. I believe in this one, we only want to delete the specific node.
Oh, so we're deleting this specific node and we're stitching everything together to like
Yes.
just, okay. Okay. And the issue is if we delete runner, it just deletes everything.
Yeah, well, it'll delete everything downstream as well. Because now there's no runner dot next to go to, right? Because there's no runner.
Okay, so then wouldn't you put runner dot next inside of the if? So if runner pointer data is equal to the target, make sure you create a blank thing, put it in the next thing, delete the runner, and then take that the temporary that we called and put the temporary and stitch that into the next one. Could we essentially do that?
Say that one more time.
I think it'd be like, I don't know. Do we have to redefine another node? Can you like create a box, like just a pseudo, like a temp, just call it temp.
Where, like just here?
Inside of the if. Okay, so that's temp. So if the data inside of runner or runner arrow data is equal to the target, take the node and then put runner, put the next. Now, I'm sorry, I'm just a little new on node still, but like, it's the same concept with like doing like transferring from a string and cutting out a character. So you kind of just you copy the next one and then you delete the current one. But when you copy the next one, you're able to take the next one and put it into the current.
Sorry, say that again.
So here, we're trying to create a copy. So like, if the current one's found to be the one we want to delete, before you delete everything, you say pause, take the one after the one we're going to delete, copy that one, and then delete the first one and take the copy and put it in the next one so we can successfully kind of like stitch it back together without first deleting the first one. We have to make a copy.
Mhm.
But I just don't know how to make that copy with nodes. Can you go back up to the next the first method again? Because it's like it's this on line 29, the moment that the while is, well, in this case we're waiting for it to equal, so but it's saying while it doesn't equal the end, take the current node and put it inside pointer, save it for later. After we take the we store the current one that we're gonna delete. We put it in the burn box that we call pointer. So pointer's gonna go away. And then we say we're gonna put the next thing in current, and we're gonna put it in current. And then we're
You
just
can
gonna
also,
delete.
Van, you can also say like node.next.
Oh, what's that do? Dot next, dot next.
That's like the reference to like the node that's like not the next one, but like the next one.
Oh, okay. It's the next.
Pretty sure you
I
can
don't.
do that.
I don't think we'll need to use next because if we're using like a while and an if, it'll do the trick for us.
So Noah, would we set that node temp? Is that the one being?
That's the thing we're going to use to dump and delete all the things that equal target.
Okay.
So for that, take node temp. Sorry, go up again. Let me just see if I can. Pointer here on line 29 is what we're going to call node temp. And then, right, okay, so node temp equals current arrow data. Yeah, can you go down? Sorry, runner arrow data. So node temp is going to be equal to runner arrow data.
You can't do that.
Oh,
Data
why?
is type
what's up?
integer and temp is of type node.
Oh, okay, so, oh, so wait, runner is the node, but when you do runner arrow data, you're accessing an integer inside of the node?
You're accessing the data of the node, yeah.
The data of the node. Okay, so, okay, so it should still work if we just say, what was it, runner? Yeah, node temp equals runner. Or we're just trying to get runner to be put inside of temp. Right, okay, and then next line directly under that. Put, how do we pass it to the next one? Hold on. Oh, also, change delete runner to delete temp. Okay, and then go back up, and then we'll pass it by. Was it runner next? The runner, can you go back up to like line 31? Right, so current. Okay, so current next equals the current. Current equals current next. Okay, then go down. It would be runner equals runner next, if I get it, if I understand it. Put that on, yeah, 44.
Runner equals runner next. I don't
So we
think
can like
we have
put
that
the, if I understand that right, we're trying to make sure it stitches. So we're gonna just like put the thing in the next and we're just gonna delete, or does that not do what we're intending to do?
I'm confused when you use words like thing. It jumbles the visualization. What do you mean by when you put the thing in next?
Put runner. Oh, well, I say thing because I have no idea what's inside of the node. We're just trying to like get rid of one node and we're trying to stitch the following nodes into one, shift at one left or whatever. However a node's supposed to be visualized. So take that runner equals runner next and put it in line 44. Right, so if runner data is equal to our target, make a node called temp and put that current runner inside of temp. Then take whatever's next in runner and put it in the current runner, delete temp, so it's gone from the node, return true, and then what, break? I don't know, because it'll, if it does that, it'll just keep on go. Oh no, return true kills it no matter what, right?
Yeah.
Okay, so return true, fine, and if not, we say runner goes to PT, and then PT. What's sorry, what's the purpose of line 48?
I don't know.
All right, if it's serving no purpose, we could just scrap it then. I mean, Zane, I forget, were you the one that put that there? I'm not,
I did,
s-
but I was considering doing a different implementation.
oh, okay,
I-
okay,
I-
so,
Totally useless.
Yeah, okay.
got you.
Wall node.
Does that look, I mean, am I making sense for, for line 43, line 44?
I don't think it's gonna work at its current state.
Oh, okay, what do you think that we can change?
Well, node temp equals a runner, and then runner equals runner next. Node temp, this is
Gotcha.
pretty much just the exact same thing as we do up here, so. So, except it's just if runner is like, if we find the target value, we're gonna delete everything downstream. But I mean, we're
Oh, but
close.
that's why we got that if. So in a sense, it is just like the one above, except that
No.
that if block just says do it that one time. Do it
No,
that
so
one time.
what we have is it currently deletes everything downstream, but that's not what we want.
Oh, how does it? So
We're just supposed to be deleting that one node, right?
Exactly.
yeah, I thought that's what it does. But then again, I don't know node. So what part of this code block tells you that it's going to delete everything?
Oh, we go node temp equals runner, so temp and
Yeah.
runner are the same. Now runner is one ahead in the list. Okay, so
Yeah.
temp is like element 1 and runner's element 2.
Yeah,
Delete element 1.
yeah,
So the first element's deleted. Now it's pretty much like we just have a new kind of thing with just the first one missing.
yeah.
And, and then we're gonna,
Return true.
I mean, yeah, it just,
That's why I
Doesn't-
created a whole different node, or what I was trying to do was create that little box that we can burn. So
like we
It's
never
not-
reconnect anything. You change the
Yeah,
value
we
of
just have to
runner
do the
and temp, but you
reconnection.
don't change the value of any of the like next, you know?
oh, do you know how to do you know how to reconnect?
I mean, do you want me to I can just type it out if we want, but if somebody wants to take a stab at it, I'm more than happy to give you guys an opportunity.
No, I know nothing about nodes, so this is as far as I can really take.
Does
it.
anybody else
You
want to
guys
have a
have more
try?
experience.
Would we need like a pointer to like a previous one?
Yeah, that's what I was planning on using PTR for.
Okay, yeah, can we do that?
Yeah, sure.
Thanks. Mm-hmm. Okay.
Oh, what does that do?
So let's see how it's like the next one is basically being set like one over the one being deleted. So it's like going over it. That's how it's being connected.
Is that what you're saying earlier for the
Yeah.
put in? Gotcha.
Well, was it getting all dark? Okay, let me see. Is that it, or are we still missing something?
No, it's not complete just yet. I mean, I'm just gonna write out
Okay.
just the issue with what I've thought of is it doesn't work for the first element if the what we're
Yeah.
looking for is in the first element, but we can just correct that once it's all written out.
So we need like a base case. So like for the base case, we could do like if um we could do like, yeah, if runner, I guess because runner is already equal pointer dot next. Yeah, if pointer data equals target, then just pointer equals. And then are we supposed to delete?
Oh, yeah.
I don't think we'd even need pointer equals pointer dot next, right?
Um, no, we will. Not sure. Let's see. Well, we need to change the list, right? So,
Hey, sorry, I'm gonna have to dip, but I'll catch the video of what you guys are doing later.
sounds good.
All right, see you, Ben.
All right, see you guys.
Pointer dot data, because, yeah, so like the node pointer, so we have that reference to the next. Okay, yeah, that should work.
This isn't the greatest, but I think it'll work. All right, what,
We get him to review it, or
yeah, Professor, I think we're ready for code review.
Yeah. All right.
Professor,
Okay,
yeah.
cool. Awesome. Let's take a look.
The
Oh,
implementation,
this is the one. Which one are we talking about?
the
Oh, this function, delete element from list. Okay. All right. So what are you doing
implementation that we
here?
came up with
If
didn't
PTR
work
equals
for the
day,
first
target,
element of the
runner,
linked list,
PTR,
so
PTR
we
equals
added an if statement to handle that.
the very first node.
Yeah,
I see. Okay. Runner not equal to null pointer. Oh, where's your runner? Runner equals pointer. Oh, I see. You're starting your runner at this next node. And runner not is null. You're going to see if runner, and you're going to delete runner PTR. Where are you? Oh, you are resetting PTR to PTR. Yeah. Okay. All right. No, that's great. That will work. If you want an extra challenge, that's good, by the way. Okay. And I think I was listening to you guys too, and you brainstorming different ways of doing this. It's very important to try wrong ways, right? And so I think that's great. And if it is possible to do it without that initial if statement that you have up there. Yeah. Now that's a challenge. I'm going to leave it in your hands. It's easy. It's actually easy. All you have to do is when you get given a list, you're going to do what you're going to do in question 9. Essentially, because this is a singly linked list, there is no way of going back. Yes. But in order to delete a node, you need to go to the back node and skip over this guy. Because it's singly linked list, you can't go back. Yes. So what we do in question number 9 is always operate one node behind. And so what we define is we define something called a cursor, who's always pointing to your PTR. That's one node behind. That's what you guys have done. Yes.
yeah.
All right. So it is possible to do it without that extra if check right there. If you, I think it is possible. I'm 99% sure it's possible to do it without that first if check. If you just treat the first node as, if you define that, this is my cursor, which is always pointing to the node before the first one. I see you still have to have a check to see if the very first node because of the cursor. Okay, yeah, maybe I'll take it back what I said. It's still possible. I suspect that it's possible to do it without the if statement, but maybe not. Maybe what you've done is probably, certainly efficiency wise, what you've done is the best. Okay, I don't think you can do it more efficiently than this in terms of CPU cycles. Also, elegance of code, meaning structured blocks look nice, laid out well, easy to read and understand. Everything here. Okay, efficient, can't do better than this. Not recursive, can do better than this. Okay, everything is there. The only suspicion I have is that it is possible maybe to write it with fewer lines of code. Not necessary, just for aesthetic purposes. So this is fantastic. I'm very happy. I'm happy you've figured out that the challenge here is to find out, hey, how can I go one node back because a single linked list, right? And then you got the PTR thing going. I think that is fantastic. Okay, because that I could have told you right at the beginning to say, use this cursor, but never as good as discovering it yourself. Now you discovered that you had to go one step back and used PTR. No amount of someone else telling you that would have had the same effect. Thank you all for striving through this, mastering this material. Mastering pointers is in fact the pinnacle of cs2a. We'll actually set you up for cs2b.
Awesome.
Thank you all. Thank you all. I'm very happy, and I hope to see you all again. Okay.
Okay, Professor, are you not doing any more office hours or anything?
Doing. No, I can do office hours. It's office hours is fine.
Okay.
Yeah.
And so the retakes are open now?
Yeah, Thursday morning until midnight.
Until tonight.
Both
Okay.
data rep and midterm.
Okay, and then the final opens on Monday?
Next Thursday.
Next Thursday, okay.
Same kind of deal with the final.
Okay.
Sean, you were really late today. Sean, are you awake?
Yeah, I'm awake.
Okay, you were really late today. We missed you for the first almost half class.
Yeah.
Yeah, but we basically picked up that code and rewrote it. So we're good there. Please follow all of the watch the video and follow all of the material here. Everybody should be comfortable at the end of cs2a to be able to manipulate pointers just like that, right? Someone just wakes you up from the middle of your sleep and says, here's a pointer, here's and a linked list. All right, and make me a three-piece suit out of it. Yeah, okay. you get your computer out and your linked list and you're ready to go. Okay, so thank you all. It's really been a real pleasure for me to teach this class. Yeah, and I really hope that the next time I have you guys, you'll be a lot more full of energy. Okay, and come fully prepared. Don't miss any classes, and master the material with equal or more zeal than this class. All right, so I'm here. If you guys have any questions later on, you can call me. If you have 3 or 4 guys who have concepts that need to be clarified, you need an extra class, reach out to me. Maybe schedule on Reddit. I don't care. I am happy to hold an extra class for you guys.
Okay.
Yeah. Because next week there are no lectures. Now, I don't think any professor is expected to give lectures next week, which means that we are free. Hopefully, if I get my next quarter materials wrapped up this week, I'm hoping to, right? Syllabus and set up a Canvas site. I'll actually have next week free to work with you guys. Okay, so if you have a request for a class or something, I will absolutely.
Okay, yeah. Are your next quarters classes, are they also gonna be 8 a.m.s or are they gonna be different?
Yeah, I try to do 8 a.m.s. But anyway, what are you gonna do? My 2As are at 8 a.m.
Okay.
Yeah, my 2C and 2B, they're purely online, but I hold voluntary lectures on request. So there's a whole bunch of students. In fact, I have more people attending my optional 2B lectures where they don't have to come to class. It was arranged on their request. I have more students come to those classes than here to my 2A where the lectures are mandatory. But next quarter onwards, a cutting class will also incur a penalty, I think, because we can say that in the syllabus now, I think. So people should not cut class, or they're going to basically drop out. So yeah, next 2B and 2C, we can do lectures any time of day. Okay, it doesn't have to be 8 a.m.
Awesome.
Thank you all. Okay, reach out to me anytime you want, and I'll hope to see you all again.
Yeah. Thank you so much, Professor. That was
no worries. Best
great.
of luck, guys. Best of luck, everything you do. Okay.
All right, thank you.
Thank you, Professor.
Bye.
Thank you. Bye.
Thank you, June. Bye.